In this talk, I will share with you my journey to build a fully working keyboard with nerves. And yeah, as Martin said, almost said, my name is André Albuquerque, and I'm a software engineer at Hopin. You can find me on GitHub as AEM Albuquerque. And some people might say I have a mild obsession with keyboards. Here you can see some projects of mine. I like to adapt old keyboards so they can be used with modern computers. On top, you can see an IBM Model F that a friend of mine brought from the US. I like to build keyboards as well from scratch. So those in the middle are two of the custom split keyboards I've built. And the one with black keycaps is the one I'm currently using. And finally, I also like to customize regular off-the-shelf keyboards. And on the bottom, you can see how I've replaced the controller of a Philco keyboard I bought in Japan a few years ago. So yes, I share with Martin this passion about keyboards. Today's talk will be about using Elixir for a keyboard controller. And we will start with the motivation behind this project. We'll introduce some nerves concepts for you to hit the ground running. And then we will start with a vanilla nerves application from scratch and iterate on it until we have a working proof of concept. This will then be followed by an explanation of how the keyboard controller actually works and some of the nice things that we get for using Elixir. We will go through some of the pros and cons of this approach, and then talk about some of the features I'd like to have in the future and things that I still need to improve. Finally, we'll do a quick demo to show you how the keyboard is working at the moment, so be prepared. Also, I had to omit some details to squeeze everything into a 30 minutes presentation, so please feel free to ask anything in the end or check the code repository afterwards. So, as I've told you in the intro, I really like keyboards. I like to customize my keyboards so I can have my own layouts instead of having to use the standard layouts out of the box. Think having the caps lock key working as a control, defining multiple layers, etc. So far, I've been using a C library called TMK to define my layouts. For the Japanese keyboard you saw on the bottom of the previous slide, this is how the key map looks like. It's no big deal, right? We just need to use the layout macro, define the key code that is sent for each position, and that's basically it. On the left, you can see how we can define multiple layers, and we can also define custom key codes. A more advanced feature that TMK has, and I really like as well. After years of using C to program my keyboards, I noticed that I end up sticking for too long with the same layout, even though I like to tweak it. This inertia is mostly due to the work I need to do if I want to update the layout. After changing it, I need to compile it with the right toolchain, and this implies having it installed in the machine I'm using. And finally, I have to burn the firmware to the controller using a specific software as well. So what this means in practice is that I end up avoiding updating the firmware after the initial setup. Meanwhile, nerves seemed so much fun. Like during the last ElixirConf in Prague, I felt firsthand the buzz around nerves and how it brings the Elixir happiness to the embedded world. And around the same time, I also found that nerves ran smoothly on a Pi Zero, and that the Pi Zero has enough I/O pins to build a keyboard matrix. All this felt like the universe was trying to tell me that it would be awesome to use nerves for a keyboard. So before we actually dive into the actual keyboard, let's quickly review some of the concepts we'll use throughout the presentation. Nerves 101. So all Raspberry Pis have an ARM architecture, okay? And this is our target. I'm building the keyboard firmware on my laptop, which in this case is the host. Here we have different architectures, right? The host is x86, while the target is an ARM architecture. So to build the firmware on my laptop, I will need to use a toolchain to be able to compile the code, and then this code compiled on my host machine different architecture will run on the target architecture, in this case, a Pi 0. The beam also needs an operating system to run on the target, and this will be our system, okay? Nerves also provides us a streamlined Linux that is build root based and that will run on the target. And so in the end, we'll create a firmware image that will contain the build root based Linux or compiled application and the glue that ties everything needed for our application to start as soon as the Pi 0 boots. So as you can see, Nerves does a lot for us. I think it's fair to say that it comes with batteries included. We just need to focus on our application. Nerves takes care of the rest. We will now start from a vanilla Nerves application and iterate on it until we have a working proof of concept keyboard. Step 1, after installing Nerves in your machine and follow the documentation, that is awesome, you can use the Nerves new generator to create a new Nerves project. If you then build the firmware and burn it to the micro SD cards, you'll get a build root Linux running on the Pi 0 and the beam running with our application on top of it. These 3 lines hide a lot of what Nerves is doing for us. It configured the build root Linux for our target with everything we need to run the beam on top of it. It created a firmware image that boots Linux and immediately starts our application. And finally, it allows us to easily write the firmware to the micro SD card with the firmware burn mix task. So, as you can see, once more, Nerves let us focus on the development of our application. We don't need to worry at all about preparing our application to be deployed on the target. Everything is taken care of for us. Also, notice that the build root Linux system out of the box configures a virtual Ethernet port over USB. This is what allows us to do SSH Nerves local and get to an EX shell running on the Pi 0. While this is very cool, it doesn't allow us to have a USB keyboard because the USB device is being used for the Ethernet port. So instead of the Ethernet port, what we want is the host to see a virtual USB keyboard. And this brings us to the second step. To have the USB keyboard instead of the Ethernet port, we will need to customize the build root Linux system that Nerves gets for us. So to do that, we pick the vanilla Linux system for the Pi 0 that is provided by Nerves. We will remove the module that provides the Ethernet port, and we will then add the kernel module that lets us configure USB devices with our application code. After this, the Elixir Key application has the ability to configure the USB keyboard in the host and send key presses to it. Nonetheless, it would be cool if we could keep the EX shell, right? At the moment, we can only send key presses back to the host. So let's go to the step 3. To continue to access our application through the network, it's just a matter of changing our config file and setting a couple of environment variables when we build the firmware. This is so easy because we are using the Nerves network library that is already included when we create the project in the first place. With the Nerves network in place, we can access an EX shell running on the Pi via Wi-Fi, and simultaneously, we can configure the USB keyboard and send key presses to the host. The only thing here is that we don't have yet a way to read the I/O pins on the Pi 0 that will be connected to the keyboard matrix. So this brings us to the final step. Step 4. To read the Pi 0 I/O pins, we need the circuit's GPIO library. This is what allows us to interact with the Pi 0 I/O pins connected to the keyboard matrix. With this in place, whenever a key is pressed on our keyboard, we can detect it, and therefore we can send the corresponding key press to the host machine. So to summarize, this is what we did in pseudocode. In step 1, we created a vanilla Nerves project nothing spectacular. Then we customize the default build root system by disabling the Ethernet port over USB and enabling the Linux kernel that lets us configure USB devices. Third, to keep the Wi-Fi access, we configured the Nerves network, and therefore we now can get to an EX shell running on it. And finally, we install the circuit's GPIO library to be able to interact with the Pi0 IO pins. So these 4 steps gave us everything we need to build a working proof of concept. So this is what success looks like after customizing Nerves. Here you can see the proof of concept I hacked together with some wires, a button and a breadboard. Here on the bottom is the key press being sent. Here on the top pane is the shell running on the Pi0 and showing some log messages. At this stage, we have all the building blocks to build a fully fledged keyboard. So we will now see how it looks like. We are building a device that is latency sensitive, right? Despite of this, I would like to stick with the OTP design principles as much as possible. Only hack to optimize if it was needed, not doing it in advance. As such, we have 2 processes under the root supervision tree. We have the GPIO listener process, responsible for scanning the matrix pins and sending a message whenever a switch changes its state. And we then have the USB reporter, responsible for translating the message it gets to a proper USB key code and then sending it to the host. With every key press, a message is being sent from the listener to the reporter, but this message passing overhead doesn't affect the keyboard, as we'll see during the demo. So let's now consider the minimum set of features that, in my view, a keyboard firmware definitely needs to have if it will replace the C firmware I'm used to use. At the very least, I need to have a way to easily define my layouts and be able to define multiple layers and as many macros as I need. So my first requirement was to have an easy way to define the layers. Here we can create a new module, okay? And this is the module I've created for my demo with the typewriter. We need to use the Elixir key layout module, tell him where is the matrix defined, and then we just need to define a layouts module attribute. This module attribute has a list where each element of the list is the key map for each layer, okay? Very similar to the TMK firmware I'm inspired by. You'll see in this layer, we have a lot of transparent key codes. That is, these ones with the underscores. So what this means is that if you press, for example, this key on layer 1, since it's transparent, it will send the key on the layer below to the host. So in your example, if you are on layer 1 and click this position, you will actually send an escape to the host. Also important, notice the toggle layer and the lock layer keys that will allow you to toggle temporarily a layer, in this case, the first layer, or lock the layer. And while it's locked, every key that you press will be sent from that layer. We'll use them during the demo. Here, my second requirement was about macros, right? I would like to define our macros as simply as possible, and I would like to record macros on the fly. So we follow a similar approach like we did for the layers, okay? On our layer 1, on the middle row, on the A, S, D, F, we are sending our 5 macros, okay? And then we are recording and replaying a macro on the fly. The macros are defined by the module attribute. That is a list as well, where each element of this list corresponds to a macro. We can define it as a simple list of key codes, or we can have a function capture that points to a function that will handle the behavior of the macro for us. It receives the state of the reporter, and it returns a tuple where the first element is the actual list of key codes that it should send to the host, and the second element is the new reporter state, if you for some reason want to update the reporter state on the fly. So some of the pros and cons of this approach, there is a lot to do, but I'm really happy with how it turned out. Like, the main thing for me is that I can redefine modules on the fly. I'm able to redefine, to tweak my layouts without having to burn anything. And this is like awesome because the feedback cycle is almost immediate. After burning the firmware to the microSD for the first time, I can always update it afterwards through SSH. I'm able to use Elixir, right, instead of C. So for me, that's definitely a plus. Some might see this as a disadvantage, but yeah, I think it's really cool to be able to use a language like Elixir to do something that is so low level, if you know what I mean. And so having a supervision tree also means that if the process works, right, I know the keyboard will continue to work. And this happened to me. I defined incorrectly a macro. The macro raised an error. I saw the error in the logs. The reporter process was just restarted with a clean state, and everything proceeded as usual. So it's good to have this sort of guarantees that with C, simply the device would break and I would need to unplug it and plug it again. Some of the cons I want to highlight are, it's definitely much more expensive, right? We are talking about 10 times more expensive. It's much slower to boot, but I think it's understandable, right? A Linux, albeit streamlined, is still a Linux that is booting up, and it's more power hungry. So I need to investigate this a bit more, but from what I've searched, how we configure the USB device with config.fx, that's the name of the kernel module, the resume and suspend functions of the device are being set to null. So I don't think at the moment the keyboard is handling the suspend or resume instructions that come from the host, but I need to investigate it more. Albeit, maybe who knows, I might open a pull request for the Linux kernel. Also something tricky for me is that the Pro Micro, albeit small, the Raspberry Pi, albeit small, is much bigger than the microcontroller, like 5 times bigger. So it's a problem for keyboards that I like to use. In terms of future work, I still need to implement a crucial feature for me, a tap or toggle mechanism. So think, if you keep control pressed, it sends the control as usual, but if you tap it, it will send another key. I use this a lot because I don't have many keys on my keyboards. Something also missing, as we discussed, is the proper power management. I need to dig more into this. And the boot time, I think we might be able to reduce it a bit, maybe by ditching some of the modules that Buildroot uses, or I have some ideas there. And finally, I would like to support other input devices. So imagine having a keyboard, but that also has a trackball included, for example, and the trackball would be controlled by nerves as well. That would definitely be cool. So final part and the fun part, when everything breaks and nothing works. We will see how it works as a simple keyboard, and then we'll start increasing the difficulty. We will look at how the layers work, how the latency of this keyboard is, and like, I'm biased obviously, but it's really acceptable. I don't feel it at all. How the macros work, how we can record macros, and then how we can tweak the layout on the fly. So for you to see the actual keyboard, I will switch cameras and we'll stop sharing my screen and we'll share it again. So please bear with me a couple of seconds. I'm now sharing my screen again. So you should now be able to see my screen. Let's move it to the demo. Can you see the keyboard here?
Yes.
Yeah, perfect. So this is the actual keyboard. So as you see, I'm not lying. I cut this from an old typewriter. This is the Raspberry Pi Zero. And this is a hacky way of me accessing the keyboard matrix. So, yeah, okay, cool. So, let me place this like here. So here on the left, we can see the code that we looked at, okay? And let's press some keys on the keyboard. And you see it's working. As you see, fast. Let me just show you the. So on the layer 1, okay, that is activated here, we have on the middle row ASDF, the macros, okay? Let me show you the macros. Oops, everything's okay. It is. Let me show you the macros. So the first macro is ABC. So if we activate, we got the ABC, the second one, XYZ. The third one is the actual, is more elaborate in the sense that we say when we want the shift to be pressed. So we get Elixir and so on, okay? The fourth one, the last one, number 4, it's calling our function here that says hello from macro function. Nothing spectacular, but it's here. No, it's here. Yes. And this shows you both the how it's working as a normal keyword, how we have layers, and how we have macros. We had the conference was scheduled for April, so I had a few extra time. So I created like some crude dashboards with live view. So let me take this out of the, so for you to see. So basically this shows you which keys are being pressed, and we have a graph with live components showing the latency of scanning the matrix and the matrix to USB latency. So like, you need to trust me, right? But it's really, I don't feel it any different from all the other keyboards I have. And you can also go here and check the logs. It's currently with debug, so a lot of gibberish going to here. And this is exactly, let's go inside the SSH shell. This is exactly what we'll see here if we attach to the logs. Let me just, so, okay. Basically, I have a logger backend that is also sending stuff to the front end through a Phoenix channel. Basically, an excuse to try this because I'm more a backend focused guy, but I wanted to try both the live components and Phoenix channels. So what can I show you now? The most important part for me is the defining the layout, right? And redefining it, tweaking it on the fly. So remember that I told you it's also able to record the macros on the fly. Currently, the age is transparent. So if I click on the age here, here, if I click on the age, I get an age, right? Because the layer 1 is sending the age on the layer above. Let's redefine this on the fly. So the age will now, on layer 1, will now start recording a macro, and the K will replay it, okay? So I come here, I will choose the full module, I will go inside the shell and I will just paste it, okay? Takes a while. And now let me show you here, for example. Let's record a macro, okay? Click on the edge. I am now starting recording a macro. I will now stop to record the macro. And then I will just replay the macro and it works. So basically, since we keep state right on the reporter process, it has a reporter state. And let's try something that I haven't tried, so it probably will work, but I think we have time yet, right, Martin? We do.
Yes, we have 10 minutes.
Cool, perfect. So let's instead of having that macro that doesn't do much, let's instead return the state of the actual reporter state just for us to see what's there, okay? So redefine it. And if we now reproduce the macro, it should have been working. Now I don't understand what happened. Let me think. Well, never mind. I need to debug this. Never try to demo something that doesn't. But oh no, sorry. I know what happened. Okay, so I was replaying the macro that I recorded, but we don't want that, right? The macro that we just redefined is the fourth one, right? And the macro number 4 is tied on layer 1 on the G, right? So if I go here and layer 1 G, I get the reporter state. Okay, so this I was thinking about, like, imagine to demo this, having like a weather API caller that you would write Lisbon and I would get the weather for Lisbon or something like that. Since we have like Elixir on there, it's just a matter of doing something more spectacular than this, okay? Yeah, I think that's mostly it. Let me just show you one thing that I for you to understand that I'm speaking the truth here. If we go to the gadget, USB gadget, this is the function that configures the USB device on the fly. So, and this is basically, I'm using some bogus IDs for vendor and product. And so here you can see the ID. This one is the last one. 1D6B0104 is our gadget. Yeah. So basically, I'm just not using it every day because I don't have the tap or toggle, and I use it a lot. But I'm planning to do that soon. And yeah, really excited. If you like keyboards, I hope you are as excited as me. Let's go back to the presentation. And yeah, thank you. And hope you enjoyed.
I think I can't speak on everyone's behalf, but I certainly enjoyed it. I cannot see any questions on Hoover yet, but I guess I can ask some questions then. So when you replayed the macros, it seemed a bit slow. Is that set because that's the fastest it can write it for some technical reason over the USB, or
I think I have a slip there, but it's slipping with a 0. So I haven't tried it without a slip at all. So to be honest, I don't know if the beam, even with the process slip, does a yield or something. But I think that might influence that. Let me send macros here. You see, macro slip between key behavior.
Yeah.
So basically, we grab that string or something, right? That binary. We have to convert it to the format that the raw write is expecting, and then we are slipping it over. Maybe if we delete this, it might be faster. But to be honest, the TMK also wasn't that fast, because sometimes, remember that if you want to be really too fast, the USB protocol also has some timings there. Yeah. So you might start getting some weird behaviors.
So questions has come in, and I guess that answers my question. There's some weird behaviors with the USB timings. Let's see, which one should be? If Samo wants to unmute his mic and ask your question. Otherwise, I can read it out. I'll just read it out. So he says, it's a lovely hardware mini project, but do you use the keyboard as a daily tool for regular work?
Yeah, as I've told you, I haven't done so far because it's missing a crucial aspect for me. That is the tap or toggle. But for example, I have some keyboards that I use specifically to write. That Model F that you saw, mm-hmm. I could probably use this as it is, since like the most important factor, latency, is already there. Okay, so I was surprised. I didn't need to tweak it, like to abandon the OTP design principles to have just one process or something, right? It's elegantly, in my view, designed, and it still works as it should. Okay, but we are seeing here like 2 milliseconds of matrix scan latency, and sometimes the matrix to USB goes to 12. These ones I don't even know. Maybe it's when we reproduce the macros.
Yeah.
So 15, 10 milliseconds. Like, to be honest, I don't know how this compares to regular keyboards, but indeed, like the subjective feeling is there.
Yeah, so I think that Tonsi has a question about getting started. If you want to unmute your mic, Tonsi, if you're able to. Otherwise, I can ask the question. What would be a good keyboard to start hacking with?
Good keyboard to start. Like, I think for you to I recommend starting small, okay? The proof of concept video I've shown, like that was a keyboard with one key, right? And the LED, but it had all the building blocks there for you to go to a fully fledged one. Because like I omitted that part, but we usually use a keyboard matrix, so we don't need as many inputs, and we need to have diodes in place so that the current doesn't flow anywhere. We just control how the matrix works basically. And I depends, right? If you want to getting started with keyboard customization, or if you want to getting started with nerves. But yeah, I think the starting even just with a button or with a switch and with the nerves, like this Pi Zeros I bought was like 10 euros. I think you can do really cool things, and like it's a joy to use as a developer, because you read the documentation of Nerves is really good. Something that you don't understand or is less polished, you go to the Slack Nerves channel, everyone is super amazing, and it's really easy to progress on your own. Okay, and that for me is the mind-blowing part.
And I guess that back when I was researching keyboards and I wanted something special, I found out that a good way to go about it is to go to one of these mega stores, online mega stores from China. I can't remember what they're called now.
AliExpress? No?
Yeah, AliExpress, for instance, and just buy one of the cheapest keyboards and just throw away the controller and replace it with your own.
Yeah, there's a subreddit, incredible, about mechanical keyboards. So if you want to start going down the rabbit hole, go there.
Yeah, and the thing is that the most expensive part is the keycaps.
Definitely.
So that's the thing. So there's a final question, I guess, unless if I reload the page. So did you learn anything new about Elixir while doing this project that you didn't know before? Or was there some feature of Elixir that really stood out?
Good question. Like, I have written a book on Elixir a couple of years ago. So it was an opportunity to revisit some of the concepts that I didn't have the chance to apply during regular work. But like, I'm fascinated by metaprogramming. And so like building this module both to define the pins of the matrix and to define the layout. This is just like use Elixir key layout, but in the back, a lot is happening, okay? This is being expanded. For example, each key of this is being expanded to a function, okay? If I go here, let me see if I can, I think we have time. If I go there and do Elixir key canon, yeah, exactly. And now layout. And we have that key code function that receives, if I'm not mistaken, the key code. Exactly, the position and the layer. And it gives you then the key code that we want. And this is all. So imagine for each key code in each layer, we are generating a function clause of key code. And this is all being done with metaprogramming. And for me, like, I really like to tinker with this. They said it's dangerous, but it's also really fun. So yeah, I think that's the main thing that I liked here.